All right. Got applications. And again, if you want to copy this into your notes, that'd be a great idea. That's a lot of words. So let's look at example 3. So on many cell phones that have GPS, you can get an approximate location before the GPS is received through a process that's known as triangulation. This works by using the distances from two known points. Suppose there are two cell towers within range of a phone, and they're about 6,000 feet apart along a straight highway that runs east to west. And the phone is north of the highway. Let's start getting some pictures going, right? So we got this highway. And there's two towers on this highway. I don't know. I don't know what cell towers look like. I don't know. Those are towers. And the phone is just somewhere north of the highway. I don't know where it is. Again, these towers are 6,000 feet apart. Good. Things running east to west. Good. Highway. Phone is north of the highway. Great. So from the signal delay, it can be determined that the phone is 5,050 feet from one tower. 5,050 feet from one tower. And 2,420 feet from the other one. Hey, we have a triangle. A side-side-side triangle. SSS. Determine the position relative to the first tower and how far it is from the highway. So the position relative to the first tower, that's going to be an angle. How far it is from the highway is this distance. That's the height. All right. So if we find, let's just do this in order, right? Because if we find theta, then we can use height by relating these three sides, right? Opposite and hypotenuse of this little sub triangle. Okay, so let's copy this picture down onto the next page. Let's get solving. All right. So, kind of probably gonna bother you that the text isn't erased. It's so weird that you can't erase it with a picture. Here, we'll scribble it out. Ah, it doesn't exist. Okay, so how do we find theta? We're gonna use the law of cosines. Now, law of cosines is gonna has a bunch of A's and B's and C's. So you don't have to, but it can be a good idea to just label these. It doesn't matter what you label them, but it can be helpful to label them. So then this is going to be A, this is going to be B, and this is going to be C. And that tells you what law of cosine to use. All right, so the law of cosines that we're going to use is going to be the one with a capital A, which means it's the one with the little a. So A squared is equal to B squared plus C squared minus 2BC cosine of A. Plug everything in, simplify, use a calculator. Again, you can also just use one of these if you'd like. Save some steps. Either way, what we're going to get is 2420 squared equals 6,000 squared plus 5050 squared minus 2 times 6,000 times 5050 times the cosine of A. Get your calculator out, unless you're really good at doing this by hand in your head. 2420 squared is, all right, this is maybe a case where using the other formula would have been better. 585, 6,400. And this is going to be 6,000 squared. 36 with 6 zeros. plus 50/50 squared. 255, 025, 0, 0. Minus that last thing, 2 times 606, 5 zeros. All right, let's subtract those other things to the other side. And that's going to give us, yeah, this one's going to be a nightmare to plug in. 585, 6400. Minus 36 million. Minus 255, 02500. Going to give us a negative number. That's okay, because there's a negative on the other side too. Negative 556, 461. 0 equals 60,600,000 cosine of A. Sorry, negative. And then divide both sides by that 60 million. So let's take this number that we just got. Divide it by negative 60,600,000. Oh crap. Why is this a problem? I missed a 0 somewhere. I missed a 0 somewhere. It's a problem that my answer is so big. I like how I made this big deal about how it's easier, or it's advantageous to use algebra with this way. But when I did use algebra, I'm messing up. No, I think I just typed it into the calculator wrong. 556, 461. 556, 46100. Oh, that's right. I think I just typed it into the calculator wrong. There's 5 zeros in the last one. Yeah, okay. 0.9183 is the cosine of A. A is going to be arc cosine of this. What's arc cosine of this? Use a calculator. Arc cosine of this, convert it to degrees. And we're going to get 23.3281. Woo, degrees. All right, so where is the cell phone? Well, it's 5,050 feet from the first one at an angle of 23.3 degrees north. That's going to be our answer. So 23.33 degrees north of east from the first tower. Right, north of east means look east and then turn 23 degrees north. I don't know why I looked up. Look east and then 23 degrees. Rotate 23 degrees to the north. All right, and that's the first half of our answer. Again, we know how far it is. They just need to know what direction. 23 degrees north of east is how you describe that. The second thing, how far are they from the highway? If they walk straight south to the highway, how far would it be? That one's not too bad. Just say the sine of 23.3281 is equal to the opposite over the hypotenuse. Multiply both sides by 50/50, and you'll get our answer. 50/50 times the sine, 23.3281. Oh, degrees. Make sure you're using degrees. Okay, about 2,000 feet. There we go. And that's the problem. Let's do one more for extra practice. Example 4. Suppose a boat. Let's get a picture. Let's get a boat that's leaving port. What's the port going to look like? Say the port just looks like a dock. That's a dock. And it travels 10 miles. Doesn't matter what direction it travels, actually, for the purposes of this problem. You could have it go in any direction. You draw some pictures to see why that's the case. It turns 20 degrees, and again, it could either turn 20 degrees up or 20 degrees down. It doesn't matter. Say it turns 20 degrees up, it doesn't matter. Then travels for another 8 miles. I'm going to make a mistake here, and I want you to tell me what it is. What's my mistake here? Right, this is an obtuse angle. This is not 20 degrees. No. When it says it turns 20 degrees, it means this angle is 20 degrees. So this other angle is 160 degrees. They're supplementary angles. So watch out for that. The question is, our little boat here, that's my boat. How far is it from port? Well, connect it with a straight line. Watch this. You want to be impressed? Connect it with a straight line, Jason. Wow, that was a really straight line. Nice job, Jason. And this is what we want to know. Oh, I'm still on straight lines. All right. So we're going to, again, use law of cosines. This triangle is actually really... I'm just going to draw the triangle a little differently. This is 10. This is 8. This is 160 degrees. And this is what we're looking for. 160 degrees actually really is this big, but it's hard to fit everything in the triangle. So we're going to make the triangle look a little different just so it's easier to have in a diagram. Okay, so we can't use the law of sines because we don't have a pair, right? We don't have a pair between an angle and opposite sides. So we have to use law of cosine. And again, it can be a good idea to just name things. So it makes it easier to use the law of cosines. So if we name things, I'm going to use a different color just to make it a little easier. It doesn't matter what we call A, B, or C. What matters is that we're just consistent. So then what law of cosines are we using? There are 3. We're going to use the law of cosines that solves for A. Go all the way back to your notes. Which law of cosine solves for A? This one. We use that. Okay? So A squared equals B squared plus C squared minus 2BC cosine. Whoa. Hold on. What is going on with my... What's going on with my triangle? How do I have 2 A's? That's interesting. Call this one C, and this one A. This is B, and this is C. I hope you were really laughing at that one. If you were typing up a comment to tell me I messed up, don't worry, I caught it. You're gonna have to erase that comment. All right, C is opposite C, A is opposite A, B is opposite B. We're solving for A. Much better. Woo. All right, so A squared, B is 10, C is 8, and capital A is 160 degrees. Simplify, or just type it in if you wanted to, right? If you wanted to, you could just type it in like this without simplifying at all. I'll show you what that looks like here. All right. You're more comfortable with your calculator. And again, we're only using the positive one. You'll get the square root of 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of 160 degrees, I'm pretty sure. 17.73 about. That's how far it is from port. And this should make sense. It should be an answer that's a little less. If we look at this picture, right? Should be a little quicker to go back directly as opposed to, like, the boat's traveled 18 miles. It's traveled 18 miles, but it didn't make a small turn. So it should be quicker if it went straight back. So it should be something less than 18. I'm actually personally surprised that it's so close to 18, but that's kind of what we're looking as a ballpark estimate for our problem. Let me know if you have questions on these. Draw some nice pictures and good luck.